Hello, I'm Professor Ben Sebitosi from the Center for Renewable and Sustainable Energy Studies, Stellenbosch University. This is a first presentation mainly on solar water heaters for the eThekwini municipality, but we also cover a couple of other applications. First, the preamble. The overview will have some background on energy basics. Then we'll look at general solar heating applications. Then we go into solar water heating, the motivation, various applications, types of collectors, and different designs and configurations. Then we look at some applications in solar heating in agriculture and commerce, way forward and frequently asked questions. The background, mainly we have defined energy as the capacity to do work. Over the past couple of decades, the terminology for energy has been evolving. We have terms like energy conservation, energy efficiency, demand-side management, renewable energy systems, rational use of energy, and alternative energy systems. Some terms are often interchangeably and wrongly used. So the purpose of this brief preamble is to clear up a few terms. For example, energy conservation and energy efficiency. Those are the most frequently interchanged terms. Conservation is about actions that we take to get the most benefit of our resources. If I switch off a light as I leave a room, that's an action. On the other hand, efficiency talks about amount. It's a measurement. What do I put in and how much do I get out? So it's the amount of energy it takes to do a certain amount of useful work. The Institution for Engineering and Technology has created a structure roughly similar to the general slogan of reduce, reuse, and recycle. But this is a bit more refined. Conservation starts at the top of the hierarchy. Before I go to the shops to buy an efficient bulb for lighting, I should look at myself first. Do I switch off the lights? After I've conserved my behavior, then I go and buy the bulb. Once my house is in order, only then can I start using renewable energy technologies. And we use this methodology to design the solar water heating system. Now, the overall spirit of renewable energy is primarily to minimize the amount of energy we consume per GDP, particularly that South Africa is carbon-based economy. This gives us a lower carbon footprint. It also saves money for the consumer. But most importantly, we have to look at the social equity aspects, job creation, and energy for all. General application for solar heating include solar water heating, which is our main topic. We have solar food drying. Others include air conditioning, and CSP, which is concentrate solar power for power generation. Applications in the water heating environment are in residential, processing industries, boiler houses, health industries, hospitality industries, food processing, pharmaceuticals, textiles, and swimming pools. Now, the motivation for residential solar water heating as a choice, mainly water consumption in the shower is a major consumer of water. And when you look at household energy in South Africa, so water heating, especially the geyser, consumes between 40 and 50% of the household energy. So this is an area where we can recover a lot of savings. Now, before we buy the solar water heater, we need to go and look at the previous hierarchy, conservation hierarchy, by consumer behavior change and energy efficient appliances. Now, this is a class discussion for your own exercise to identify what measures you would take before you proceed to buy a solar water heater. Example, if you take half an hour in the shower, it would be advisable that you cut down on the number of hours, of minutes, and then maybe you look at your shower heads as well in terms of amount of water they spill. So that is your behavior change and appliance improvement. And then, only then do you proceed, because that gives you a way to size your solar water heater appropriately. Now, the anatomy of the basic solar water heater involves two main items: the storage tank and the solar collector. We'll look at it in more detail. There are two types of collectors. We have the flat collector and the evacuated tube. The evacuated tube has a major advantage in that it receives the radiation the same way throughout the day. In the morning, it's perpendicular, and in the afternoons, it's perpendicular. And it has good insulation, so it has good performance in cold seasons. On the other hand, flat collectors have a price advantage. They're cheaper, and they have been around for longer. However, prices for tubes are dropping, especially with aggressive markets from China. There are systems. We have passive systems and active systems. The passive system entails the tank, the collector. The tank is higher, as we'll see. This is also called thermosiphon. Cold water comes from the tank and enters the collector. This is the solar energy. The collector heats the water which flows to an upper part of the tank. So the warm water rises through a thermosiphon process and goes back to the tank. The location, it can be directly coupled, or it can be positioned in the ceiling, but it has to be higher than the collector for thermosiphon for the passive system. Because it's heavy, your ceiling structure must be strong enough to support your roof, your systems. The active system, on the other hand, involves mainly the pump. And because the tank is in a position, thermosiphon only happens in an upward direction. So in this case, the tank is lower, or in any location, you need an active pump to move the water in the system. Again, the cold water is at the bottom, and the pressure of the pump at the bottom pushes the water back to the tank at the top. The tank can be located anywhere in the household. Now, there are attributes on the passive and active system. The passive system saves energy and is easy to maintain. It doesn't have that pump which has moving parts which needs maintenance. However, the active system can be located more conveniently. It's also lightweight because you don't need a tank on the roof. And you can use an existing tank, because most geysers have their tanks somewhere in the house, and when you have to put a solar water heater as an additional accessory, then you have a problem if you don't put in a pump. So the disadvantages is that the close location of the tank reduces the losses in the pipe, but the pump uses some bit of power, so you have some power. Now, installation. Normally in South Africa, the installation faces, the collector collects the solar energy, which has to face the north, because we are south of the equator. However, a lot of plots and houses are not conveniently facing north. And so in that case, if you find you are not, the roof is not facing the north, you can vary by up to 45 degrees without losing too much energy. In terms of angle, most households prefer the collector to be flat on the roof because of the aesthetics. Ideally, the angle should be the latitude where you are, again facing north. But it can be plus or minus 10 degrees. In case your roof is facing some other direction other than the north, you can drop the angle to as low as 10 degrees to give you good performance. Now, temperature protection. In cold seasons, there are problems about freezing, especially for flat collectors. Places like Bloemfontein, the Free State, and Joburg, you have freezing. In those places, the vacuum tube can survive a lot better when the conditions are not too severe. When you have very severe conditions, then you need indirect flows, where what we call a closed system, where you put an unfreeze fluid in the circulating fluid, but that fluid does not get connected to the tank water. Other circumstances, you can use a valve, a frost protection valve, which is temperature controlled. Once the temperature is too low, the flow is cut off. On the other And in summer, you get high temperatures where the tank may boil. So the precaution is to use to stop the saturation. Normally, traditional valves on the tank are not adequate for this application. So stopping saturation is the most advised intervention. There are regulations by the South African National Bureau of Standards that regulate qualities and procedures about solar water heaters. Now, sizing the system. How big should your system be? Unlike photovoltaic systems, solar water heaters are currently not rated, and therefore sizing is a bit more difficult. Normally, one uses past history. If you have a good installer in the area, he will be able to advise from previous experience what they have done. But experiences are different in different regions of the country because there are different levels of solar energy in different parts of the country. Resource assessment is advised, good training of service providers, and standards compliance. There are also, of course, ethics. So you need to use recommended service providers. In addition, most commercial solar water heaters come in fixed sizes, so you may not have much flexibility. But again, it is wise to use an experienced service provider. There is a software tool which is available on Red Screen. You can Google it, or you can go directly to their website. It will help with sizing. Best usage practice. There are social issues about how much energy you extract out. The sun comes during the day, and the tank loses heat during the night. So it is wiser to shower in the afternoons and evenings. That's the best practice if you want. On the other hand, if you shower in the morning and your heater is connected to an electric system, then this heating system will heat up the water before the sun comes, in which case you will not be able to utilize the solar energy. So you need timers which switch off the geyser electric system to allow you to allow this solar system to function. There are legends that showers save energy, save water, but this has been disproved. So your behavior is very important. So reduce consumption, use low flow shower heads, turn off water. These are just habits which are generally common sense. If you go to a local hardware, they will be able to advise you on the right shower heads for different applications. Maintenance. You require periodic inspections for your system. Just check for problems, components that need to repair and replacement. There is scaling if you're in a region where there is hard water. The water is hard and corrosion and so on. Shading is a big problem. If you are in a shaded area with trees, they reduce your energy. Soiling as well. Soiling, dust, depends on how dusty the environment is. Their seals, plumbing ducts, all these actually require a trained plumber. Roof checks, support structures, relief valves are some of the areas where one checks for maintenance. Pumps, heat transfer fluids, and the tank itself. Now we are going to look at heating solar heating in the agricultural sector. Traditional heating, traditional drying has issues such as birds coming to eat your food and hygiene and so on. So it is also slow, quality, spillage, and requires large areas. Solar dryers, on the other hand, are useful from a conservation perspective. They occupy less area and improve the quality and color of your produce. So agriculture, crop drying, food processing industries are some of the applications. Fish and meat drying, dairy, timber, and textiles are some of the commercial applications. Now, this is the general structure of a solar dryer. You have a collector. Hot air rises by convection. This is the chamber where the produce is stored, and this is the outlet. Different designs. You have what you call a tent dryer. Consists of wood poles covered in plastic sheeting. It's something that can be fabricated by anyone quite easily, and it's quite efficient. Food is placed on the rack. This is another type of dryer called a box dryer. It's used mainly for small scale. The inside is painted. And this is mainly the function you have. The transparent solar radiation goes to the produce, and again, air flows through the produce. This is the box, the chamber. This is a different design called the greenhouse design dryer. This is a much larger scale of a greenhouse. And this is the inside of a greenhouse. Now we look at what most people ask, frequently asked questions. How much do I save when I install a solar water heater? Now, installation should initially act as an opportunity to conscientize the household members about energy conservation, about water conservation. Most of the saving happens in the conservation area, even before the solar water heater comes. It cannot be overemphasized that a solar water heater will not save you energy if you waste in terms of behavior. It also depends on the annual solar radiation. In other words, where you are located will determine how much energy you save. If you are in Uppington, your solar water heater will work better than when you are in Cape Town, for example. And it also depends on the prevailing tariffs. If the power tariffs are high, then your payback period obviously is shorter. Ideally, a solar water heater should face north, but existing properties may dictate where it faces, and that will compromise on how much you save. A professional, competent service provider should be able to advise you. Thank you very much.